Hello students, let us continue with normal distribution. We'll start with the sixth problem. Let x be normally distributed with mean 100, so mu is 100, and standard deviation of 5, so sigma is 5. So they've given you this diagram. On the diagram below, shade the region representing p of x greater than 105. Now this is actually a non-calculator question. So this is 100 and 105. So this is how we represent this, right? P of x more than 105. Now the second part is, it is given that P of x less than d is same as P of x more than 105. So definitely d will be in the left hand side of 100. So what they're saying is this area is same as this area. So now using the property of symmetry, so this is 5, so definitely this distance will also be 5. So d is nothing but, they are asking you to find the value of it. D is nothing but 100 minus 5, 95. And the third subdivision is, if P of x more than 105 is 0.16, then find the probability that x will take the value between d and 105. Okay, now this area is 0.16, which means this area is 0.34, isn't it, students? 0.5 minus 0.16. So obviously this area will also be 0.34 because using the property of symmetry. So the answer is 0.34 into 2, which is 0.68. So the area between d and 105, or the probability that x takes the value between d and 105, is nothing but 0.68. Okay. Let us look at problem number 7. A box contains a large number of biscuits. The weights of biscuits are normally distributed with mean 7 grams. So mu is 7 and a standard deviation is 0.5. So sigma is 0.5. One subdivision A, one biscuit is chosen at random from the box. Find the probability that this biscuit weighs less than 8 grams. So I need to find what is the probability that x is less than 8. So we need to go to distribution, normal, go to NCD. I want less than 8, so 8 and below. So lower limit is minus 10,000, upper limit is 8, sigma is 0.5 and mu is 7. So you'll get 0.977 as the answer, right? In case, now it is not mentioned in this question, in case if they ask you this question, let's say 2 biscuits are chosen at random from the box. Find the probability that both the biscuits weigh less than 8 grams. So in that case, the answer will be 0.977 into 0.977. Many of the students write it as 0.977 into 2. That is wrong. So 2 biscuits, both of them weigh less than 8 gram, means first one should weigh less than 8 gram, that is 0.977, and means multiplication. The second one also should weigh less than 8 grams, again 0.977. So basically 0.977 squared. Okay. Now let us look at the second subdivision. What is the probability that the biscuit weighs between 6 and 8 grams? So again, go to this one. I mean, lower is 6, upper is 8, and sigma and mu are same. So the answer is 0.9544. So 954, right? Okay. Now subdivision B. 5% of the biscuits in the box weigh less than d grams. So that means probability that x is less than d grams is 5%, so 0.05. Copy and complete the following normal distribution diagram. So there is a normal distribution diagram like this. You need to copy this information to represent this information by indicating D and shading the appropriate region. So this is the mean, which is 7. Now since this area is 0.05 is less than 0.5, so definitely D should be in the left hand side, isn't it, students? So shading. So this is the answer. So this area is 0.05. Now the next question is find the value of D. So you go to inverse normal. Now you can see the tail is in the left hand side, left. The tail is left. So tail is left. Area is 0.05. Sigma is 0.5. Mu is 7. So the answer is D equals 6.177. So 6.18. The value of D is 6.18. Yeah. Now the final subdivision. It's given that the weights of biscuits in another box are normally distributed with mean mu and standard deviation 0.5. So mu is given, I don't know the value, it's not given. Sigma is 0.5. It is mentioned that, it is known that 20% of the biscuits in this second box weigh less than 5 grams. So P of X less than 5 is 20%, so 0.2. Find the value of mu. As I told you earlier, students, whenever you're supposed to find mu or sigma, you need to convert the x into z. So how do you do that? You write P of x minus mu by sigma is less than 5 minus mu is 7 by sigma equal to 0.2. That means P of x minus mu, I can write it as z, right? Let me write it as z. So P of z less than, because this is z, minus 2 by sigma equal to 0.2. I'm sorry, I think I made a mistake again. We have to find the value of mu, right? So they are given sigma and we have to find mu. So let me just erase this. So what is given? P of x minus mu by sigma is less than 5 minus mu by 0.5 equal to 0.2. That means P of z less than 5 minus mu by 0.5 equal to 0.2. Now I can take this as say some a. So P of z less than a equal to 0.2. Now what I'll do is I will use the inverse normal option in the calculator. Inverse normal. The less than a means the tail is left and area is 0.2. Sigma is 1 because I have converted the x into z, and mu is 0. So the answer is minus a is minus 0.8416, so 842. So which means 5 minus mu by 0.5 equal to minus 0.842. So mu is nothing but 5 plus 0.5 into 0.842. So this is the answer. Yeah, quite simple. Let us look at the eighth problem, students. The heights of certain plants are normally distributed. The plants are classified into three categories. Category A, the shortest, 12.92%. Category C, the tallest, 10.38%. And category B is between. So if I have to represent this, so I'll draw like this. Draw here. This is the mean, mu, this is the mean, and so now all other plants are in category B with heights between R and T. So let us say this is R and this is T. This is the shortest, this is the in between, this is the tallest. Yeah, and it is mentioned 10, the tallest 10.38 percentage or in category C. That means this area, students, this area is nothing but 0.1038, and the shortest 12.92% is in category A, which means this area is actually 0.1292. Okay, now it is mentioned that it's given that mu is given as 6.84 and standard deviation is 0.25. Now using this information, find the values of R and T. Now we know that P of X more than T is 0.1038, right? So area is given. I can use the inverse normal option in the calculator. So the tail is right? The tail is right. So the tail is right. Area is 0.1038. Sigma is 0.25 and mu is 6.84. So the answer is T is 7.155, so 7.16. Similarly, P of X less than R is 0.1292. So again, let me use the inverse normal. This time the tail is left and the area is 0.1292. So the answer is R is 6.55, so 6.56. Right? So T is 7.16 and R is 6.56. So that's all done. Let us look at the next problem now. The scores of a test given to students are normally distributed with mean of 21. Okay, so we have mu is 21 and sigma is not given, so question mark. 80% of the students have scores less than 23.7. That means probability of a score being less than 23.7 is 80%. That means 0.8. The first subdivision is, using this information, find the standard deviation. So quite easy. You need to convert the x into z. So P of x minus mu by sigma is less than 23.7 minus mu is nothing but 21 by sigma equal to 0.8, which means P of z less than 2.7 by sigma is 0.8. So I can take this as A. If P of z less than A is 0.8. Now the area is given, I need to find the value. Use the inverse normal option. Now less than A, that means the tail is left. The area is 0.8. Sigma is 1, isn't it? Because I have converted x into z. So sigma is 1 and mu is 0. So the answer is, this A is nothing but 0.841. So 0.842, which means 2.7 by sigma is 0.842. That means sigma is 2.7 divided by 0.842. Yeah. So you'll get 3.21 as the answer. 3.21. So sigma is nothing but 3.21. Yeah. Fine. Let us look at the next subdivision. It's given that a student is chosen at random. This student has the same probability of having a score less than 25.4 as having a score greater than B. Find the probability that this. Okay, so let me try to draw the diagram and explain it. It's much clearer if you draw the diagram. So this is the mean 21, right? And it is mentioned that this student has the same probability of having a score less than 25.4. So definitely 25.4 is here. So this area that is less than 25.4 is same as having a score greater than B. That means B will be, let's say B is here, more than B. That means this area. So both the shaded part, the black one as well as the red one, are actually same, which basically means that this area and this area have to be definitely equal, isn't it, students? So using the property of symmetry, we can easily deduce that if this distance is 4.4, then this distance will also be 4.4. So in fact B is nothing but 21 minus 4.4, which is nothing but 16.6. Okay, fine. Anyhow, I think that is the second part. The first question is, find the probability. What is P of x less than 25.4? So the answer is, you can use go to statistics, distribution normal, go to NCD. Lower limit is minus 10,000, upper limit is 25.4, sigma is we found it 3.21, and mu is 21. So the answer is 0.915. 0.915. So the second subdivision is find the value of P. You can find it in two ways, using like this as I mentioned, using the property of symmetry you can use it, or you can also say P of x more than B is 0.915 according to the problem. So now I can use inverse normal. The tail is right, area is this. So if you use the calculator, you'll get B as 16.59, which is nothing but 16.6. Yeah, the same answer. Let us do the 10th one, students. Quite simple problem. A random variable x is distributed normally with a mean of 100. So mu is 100, and standard deviation is variance is 100. So sigma is 10, square root of 100. Right? Now the first question is, find the value of x that is 1.12 standard deviation above mean. That means x is nothing but mu plus 1.12 times sigma. That means 100 plus 1.12 times 10, which is nothing but 100 plus 11.2, so 111.2. And B is, find the value of x that is 1.12 standard deviations below the mean. That means x is mu minus 1.12 times sigma, so 100 minus 1.12 times 10, so 100 minus 11.2, so 88.8. So the problem is over. 11th problem is, the heights of trees in a forest are normally distributed with mean height of 17 meters. So mu is 17. One tree is selected at random. The probability that a selected tree, any selected tree, has a height of greater than 24 is 0.06. So it is given that P of x more than 24 is 0.06. Probability of selecting a tree whose height is more than 24 meters, greater than 24 meters, is 0.06. The first question is, find the probability that the tree selected has a height less than 24. That means, what is the probability that P of x less than 24, which is nothing but 1 minus 0.06, so 0.94. Okay, Now the B part is, this is A, subdivision A. Now the subdivision B is, the probability that the tree has a height less than d meters is 0.06. So P of x less than d is 0.06. Now we can see that this is the same as P of x more than 24, isn't it, students? P of x more than 24 is also 0.06. P of x less than d is also 0.06. So the question is, find the value of d. What we need to do is, we need to draw this curve. This is the mean. This is 17. This is 24. This area is 0.06. Now, so d should be in the left hand side. This area is also 0.06. So as now, using the property of symmetry, this distance, this distance is 7. So definitely this distance should also be 7. So it is quite easy to note that the d is nothing but 17 minus 7, which is 10. So the value of d is 10. Now the final subdivision is, a woodcutter randomly selects 200 trees. Find the expected number of trees whose height lies between 17 and 24 meters. Okay, so now P of x between 17 and 24. What is it, students? That means I'm talking about this area. I'm talking about this area between 17 and 24. Now, if this is 0.06, don't you think this will be 0.44? Now, you may wonder, how do we get this? Very simple. This whole area is 0.5, right? 0.5. So definitely this part will be 0.44. So 0.44. So what it means is, probability of finding a tree whose height is between 17 and 24 is 0.44. Again, what it means is, out of 100 trees, 44 trees, 0.44 means 44 out of 100. So 44 out of 100. So out of 100 trees, 44 trees will have heights between 17 and 24. So if I take 200 trees, definitely it will be 88, isn't it? So basically what you need to do is, the question is, find the expected number of trees whose height lies between 17 and 24. So the answer is 200 multiplied with 0.44. So answer is 88. So you can find 88, you can expect 88 trees whose height may lie between 17 and 24, right? Fine. Let us do the 12th problem, which is quite sort of challenging. The speeds of cars at a certain point on a straight road are normally distributed with mean mu and standard deviation sigma. So they are not given the value of mu and sigma. We need to find it. 15% of the cars traveled at speeds greater than 90. That means P of x more than 90 is 15%, so 0.15. Okay, so I'll just draw a line here. And 12% of them at speeds less than 40. So P of x less than 40 is 12%. So, sorry, so 0.12. Right? Okay, so find the value of mu and sigma. So what we do is, I'll convert it into z. So P of x minus mu by sigma greater than 90 minus mu by sigma is 0.15. That means P of z more than 90 minus mu by sigma is 0.15. Now here, same thing, P of x minus mu by sigma less than 40 minus mu by sigma is 0.12, which means P of z less than 40 minus mu by sigma is 0.12. Now here area is given, we need to find the value, so I'll use the inverse normal. So go to distribution normal. What you need to do is now go to inverse normal. Now here the tail is greater than 90, that means right hand side, so the tail is right and the area is 0.15, sigma is 1 and mu is 0, isn't it, student? Because I converted this into z, so you get 1.036, so 1.04. So this 90 minus mu by sigma is nothing but 1.04. Okay, now let us consider this. Here again, go to distribution, go to normal, go to inverse normal. Now here for this, the tail is left, okay, less than, so tail is left, area is 0.12, so 0.12, sigma is 1 and mu is 0. So you get minus 1.174. So you get 40 minus mu by sigma is minus 1.174. So minus 1.17. Okay, you got two equations. So what you need to do is, if you simplify, you'll get mu as 90 minus 1.04 sigma, and here you'll get mu equal to 40 plus 1.17 sigma. Yeah, if you simplify this, so you can equate both, so you get 90 minus 1.04 sigma equal to 40 plus 1.17 sigma, which means 1.17 sigma plus 1.04 sigma equal to 40 minus 40 plus 90. So you basically get 2.21 sigma equal to 50. So sigma is 50 divided by 2.21. So find the value of sigma and then you can find the value of mu. So basically you get a simultaneous equation in mu and sigma. Fine. Let's look at the 13th problem in the worksheet. The heights of boys at a particular school follow a normal distribution with standard deviation of 5 centimeter. So sigma is 5, mu is not given, mu is a question mark. The probability of a boy being shorter than 153 is 0.705. The probability of a boy being shorter than 153. So probability of x less than 153 is 0.705. Calculate the mean height of the boys. So how do you do it? Obviously you have to convert this into z. So p of x minus mu by sigma is less than 153 minus mu by 5 equal to 0.705. That means p of z less than 153 minus mu by 5 equal to 0.705. Now I need to find mu. So I have the area, I need this value. So go to inverse normal. So distribution normal, inverse normal. The tail will be left because I have less than 153 minus mu by sigma. The area is 0.705. Sigma is 1 and mu is 0. You get 153 minus mu by 5 equal to 0.5388. So 0.539. So mu is nothing but 153 minus 5 times 0.539. You can get it. Yeah? So once you find the mu, the next subdivision is, what is the probability that a boy is taller than 156? So p of x more than 156. So you can use the calculator to find the answer. Once you have the mu, then you substitute the mu and sigma and you can find the answer. Okay, fine. We'll stop here, students. So what I'll do is the rest of the problems I'll try to record it in a third video. Yeah, so I'm sorry, this is actually 2, right? This is normal distribution 2. Yeah, thanks for watching this video, students.